Morning, guys. We're going to start going over electrical systems today. We're starting to go into the utilities phase, and it's nice to lay out our electrical systems really before we get into some of the other ones. So I thought I would take today and go over this with you. Electricity, it can be dangerous. My nephew tried to stick a penny into a plug. Whoever said a penny doesn't go far didn't see him shoot across that floor. I told him he was grounded. That's a Tim Allen joke. Don't blame me. Anyways, the things that we're going to be going over here. First one is basic electrical systems. We want to talk about electrical service, what electrical power is, and more importantly, power distribution. Power distribution includes the building wiring, the receptacles, the switches, and a lot more than that goes into it. This is the electrical system, but when the electricians are running their wires, that's when a lot of the other low voltage controls, Ethernet controls, lighting controls, and internet are laid out in the past, and in some areas still also coaxial for television services. We're going to touch down on electrical codes, electrical plans, and electrical conservation as well. So we'll start by going over the electrical system. The components that are included in an electrical system are the basic meter, service panel, the building wiring, electrical boxes and receptacles. The boxes are behind the drywall in the house, and they hold the outlets. They are attached usually to the side of a stud, or a 2x4, or 2x6 if they're using 2x6 studs. And switches, the lights, and equipment powered by electricity. Some other electrical systems, as I already stated: entertainment, cable, home theater, audio systems, etc. Telecommunications for home phones, non-mobile. Also for security systems, intercoms, and such as this. The electrical service, that's when the electricity is supplied to a building via a service drop, which is 3 wires. This is for a single phase system, and I'll get into that, the difference between single phase electricity and 3-phase electricity, more when we get into commercial wiring. 3 wires, 2 wires that carry 120 volts of alternating current, or AC, such that the voltages are opposite. 1 wire is neutral or ground with 0 volts. Building electrical circuits are powered by the difference between any 2 wires. 120 for most fixtures and appliances, and then 240 is needed for certain applications and appliances like dryers, stoves, hot tubs, for you guys who work in the garage, the welder, and some other tools like that too. Some other common home tools that can also incorporate 220, such as drill presses and things like that you'll find in a shop. Looking at the electrical power, wait a minute. Before I get into electric power, I want to touch base on electric service. When they talk about 2 wires carrying 120 volts of alternating current, you have actually 4 wires. You have a ground wire, you have a neutral wire. Both ground and neutral go back to the panel and connect together as a ground. A neutral is an open circuit for them. The 2 positive wires, if you cross any of these wires, any of these 3 wires, neutral or ground, with either one of the 120s, it's going to arc and short. But if you cross the neutral and the ground, because they go back and connect to the same thing, they will not short. If you connect or touch the 2 120s together, they will arc also. In the lower right hand corner here you see this little diagram of the sine waves, the green being the neutral and the blue and the red being the two opposing 120 volt leads. Okay, moving on to the electric power. Power is the rate at which energy is used, and it's measured in watts. An electric meter measures electric power running through it. Energy cost is equivalent to the power or rate times time. It's rated in kilowatt hours. You'll find this meter on the outside of the house where the power comes into the building. For power distribution, we're talking about the circuit breaker panel in your house. It's a power service that's supplied from the meter, coming in directly through the top to the main breaker, and it distributes power to the building. Main breaker allows power to be switched off. Smaller circuit breakers allow individual circuits to be switched off, or if there is a short in the circuit, they will automatically pop. And then they need to be reset. If they continue to pop, you have a problem that needs to be dealt with. Let's go on to building wiring. Sheathed cables contain black, white, and green or bare ground wires, as shown in the picture. Electricity is fed to a device via the hot wire and returns, completing the circuit through the neutral wire. The ground wire provides a safe path for electricity if a short circuit accidentally occurs. The receptacle itself, an outlet which is to connect electrical devices to power. It allows a continuation of circuit through hot, neutral, and ground wires and cord. The socket pattern corresponds to standard neutral slot longer than the hot spot, and grounding socket is rounded. So the two rectangular eyeballs, the smaller one provides power, and it is in turn returned via the ground circuit, or what looks like the little surprised face's mouth. The neutral slot is in essence another ground wire for safety factor, so that if something is interrupted through the ground socket and there's a short in the equipment, it has another return back to the panel or through the circuit, so that it does not use you as a ground. Okay, and with that we'll talk about ground fault circuit interrupters, or a GFCI or a GFI as often referred to. They're required by code in potentially wet locations, such as kitchens and bathrooms. The circuit is opened, it stops the circuit when short circuit occurs. Okay. It should be noted that you may not have a circuit or a receptacle like this in your bathroom or right next to your sink. In North Carolina, you are allowed to have a remote located GFI. In my house personally, the two of these are in the basement, so if you pop one off in the bathroom, you have to go all the way down to the basement and press the little reset button in it. So it does not mean, although there's no way to really tell just by looking at it, if there is one in the wet location in the room that you're discussing. It should be one next to your sink as well. Okay, let's talk about switches. The first one is a common one, which everybody is used to, a single pole electrical switch. It allows switching from one location. Typical installation, power comes into the switch, toggle, excuse me. The switch toggles to open or close the circuit, and then the power travels to the light or the equipment. Excuse me. When you toggle a single pole switch, you close the circuit when the switch is in the on position so that the electricity flows to the light or the device, and opens the circuit when the switch is in the off position so that no electricity flows. Each switch is housed and a switch box. That's the blue box in the image at the bottom. Okay, let's talk about a double pole single throw switch. As illustrated in this position, one switch flips the power and connects two circuits, allowing switching two circuits from one location. Similar to a single pole switch, except two circuits are opened or closed with a single switch. A three-way electrical switch. These are common in rooms like living rooms, where you can enter the living room from one room, turn the light switch on, then leave the room via a hallway and flick the switch on the other side to turn it off. Although they're labeled a three-way switch, it indicates that three switches should be included. A three-way switch is a switch that allows a connection to a second switch, not another device. Toggling either switch will turn the device on or off. Going into electrical codes. Local jurisdictions may have unique electrical codes or requirements, or may adopt a model code. The International Residential Code includes residential electrical requirements. The National Electrical Code, NFPA 70, is a model code that provides guidelines for designs of electrical systems. Okay, moving on, we'll go into electrical plans. That's what you're looking at when you look at the diagram for a house to be built. This electrical plan illustrates how the electrical design is often documented using an electrical plan. An electrical plan identifies the electrical and the lighting fixtures to be installed in a building as to where they're going to be on the wall. The dashed lines are switch legs that represent the wiring between a switch and the electrical components that control it. In this design, all of the components that it controls in the design, all of the lights that are controlled by switches. Outlets and other wired equipment can also be controlled by a switch. Note the use of single switches in most cases, except where the two switch controls in the same light or group of lights, where a three-way switch is used. A small 3 next to the switch symbols indicates a three-way switch. The electrical installations are not complicated. The electrical plans can be placed directly on the floor plan. Often a separate electrical plan will show all electrical fixtures and light fixtures. However, for more complicated commercial and industrial designs, the designer will create separate power plans and lighting plans for the different contractors. The power plan can show wiring for electrical outlets and electrical equipment, and the lighting plan typically shows just the light fixtures and the switches. The legends are keys that identify symbols used on the drawing view. The legend identifies the electrical and the lighting fixtures that are used on the previous electrical plan. They can be much more complex and much more extreme than this one. This is a simple one for a house such as the Habitat for Humanity, which you guys are working on now. Energy conservation. Some tips to provide energy savings when designing an electrical system. Minimize electrical outlets and recessed appliances in exterior walls. Install timed switches or humidistats and exhaust fans to control unnecessary ventilation. Select energy efficient appliances and equipment. Use energy efficient fluorescent lighting where practical. Use recessed lighting fixtures that are rated for insulation covers. The only thing that I would dispute on this is minimizing electrical outlets. As we grow more and more dependent on electricity, it is much easier to provide more outlets when the house is built than to go back in and rerun new wires and install them at a later point. Most any contractor is going to try to sell you on more outlets while the house is being built. there's a standard number that are acceptable for standard rooms now. Uh, you know, more so have always been the rule to have more in a living room or in a kitchen. But now with the use of chargers and so many devices, digital devices, and the need for more outlets, the rule usually was one or two in a bedroom, but you're going to find in new built homes many more electrical outlets. Just for that reason, it is so much easier to run them when the house is being built than it is to come back at a later point. So we've gone over the electrical system, the electric service, the electric power, power distribution, building wiring, receptacles, switches, electrical codes, electrical plans, and energy conservation. The next thing you're going to need to have for an assignment is you're going to have a large, clean layout floor plan of your home design. And then you are going to do the electrical plan and the layout for your home. I will talk more about that on Monday's Haiku page. So come on back and see me then. Guys, have a great day.